Hello, good evening, students. So I'll be discussing the digital image processing, the image enhancement part for this fourth lecture, which is regarding the point processing. So so far we have looked into the histogram image processing based image enhancement technique. So going ahead, the contents of this lecture will consist of what this point processing is, what are negative images, thresholding, logarithmic transformation, power law transformation, real level slicing, bit plane slicing, and so on. Next, the first thing that we do in basic spatial domain image enhancement is that we have an initial pixel fxy, and we have a output a pixel gxy. So we do some transformation such that this fxy turns into gxy. So that is the basic idea. So next, here for any operation, there are different types of operations which may be this particular denoted by this particular t, and which is the operator, and it is defined over a particular neighborhood of xy. Now coming to the point processing, it is the simplest of the domain operations that occur when the neighborhood is simply the pixel itself, and in case this operator T is referred to any gray level transformation or any point processing operation. So we have R being the input pixel and S being the output pixel value. So like this particular example of negative image based things, you can see here in the left side the mammogram image, which is done in normal, say, full body checkup or so for the ladies. So there you have a darkened image of the mammogram, but here we want to locate tumors and other things, and it is much clearer if the tissue is the negative image of the mammogram compared to the positive image. So what we do, we do a transformation. Here S is equal to 1 minus R, where 1 corresponds to 0 to 255, means 255 is 1, and R is the whatever is the pixel intensity. So by doing this transformation, the whole negative image turns into a positive. To show you very common in MS Paint, I will open any MS Paint. Now here, if I draw any particular, say, square like this, and we have a circle inside, and then we color it, say, red, and say outside is something like green. If I select the whole image and I right click and I invert the color, this is the, so you have magenta and cyan here, whereas if you see the inverted, it is actually red and green. So in the red, the red channel is on, and that if you want to see clearer, you can use blue also here, and you can see red, green, and blue are here, and we have this whole thing inverted as a yellow sign, though it is not a pure blue, so that's why you are not having a pure yellow here. So you have magenta, cyan, and yellow, and the black has become white. So you can see the inversion that we are seeing here. So this is a very common operation, the inverting. You can have anywhere. I'll be discussing the inversion soon. Going ahead, we have this for negative images, we just have the maximum intensity minus the pixel value, giving you the output intensity. Similarly, we can have thresholding, where we can convert any grayscale image into a binary image comprising of only 0 and 1 bit, or say 0 or 255. Here the idea is that based on any threshold that we decide, what we can do is that we can consider anything below this threshold as 0 and anything above the threshold as 1, and we can get a binarization of the image. I'll be discussing the programming soon. So here we have this input and output relationship. Moreover, the intensity transformations may be simple thresholding kind of like this in the right, or it may be a sigmoidal where you have a part analog and a part digital. So you can have any kind of operation. Only thing is that you have to input the mathematical operators in a proper way in the program, and you have seen that in Adobe Photoshop how they are making these corrections. Before going to the gray level transformation, let us discuss the initial few programs. The one most common one is, say, if we do the multiple threshold thing, here we have for j equal to 0.15, j equal to zero point 0.3, j equal to zero point 0.5, j equal to zero point 0.7. If I run this, you can see that we can have different thresholds. You can have the original image here, and you have the grayscale version of this papers.png, and you have, when I have put threshold equal to zero point 0.1, this is the condition. When I put zero point 0.3, this is the condition. When I put zero point 0.5, it is the condition, and when I put zero point 0.8, this is the condition. You can see this, and we can combine these thresholds, and we can have something like a 2 bit or 3 bit kind of color, where we can keep, say, I have kept 0, 75, 150, 200, and 250 as the pixel values. So yeah, I have only 4 pixels or 5 pixels here, which can be represented by 3 bits. So this grayscale image is represented in this way. So original image histogram is this, and by thresholding respectively, so I can combine the thresholds and I can have an image like this. So you can see here I have 0, 75, 150, 200, and 250. You want to see the code? This is the coding that we have done here. So if you go for the color version also, you can do this kind of thresholding in color also, where you can see here we have different intensities. So if this is the red channel, green channel, and blue channel version of the color image, we can use different random threshold like 0.4737, 0.2604, 0.2206 version. So I have random specialization. Now what I can do, I can combine these to form the color. So these three forms this color image, and these three form this color image. So if I maximize, I think you can see that this is the original color, and this is the thresholded color with R equal to 4737, 0.2604, 0.2604 for green, and 0.2260 for blue. So you can have these kind of operations here. Next, after this, I'm going to the next part, that is the basic gray level transformations. Here we can have different kinds of gray level transformation, negative ones, or you can have logarithmic power law. You can see when it is negative, this is the input and this is the output, it is reverse. When it is identity, it is in this side. Similarly, we can have log or inverse log, nth root or nth power kind of thing. And for logarithmic transformations, we can have c into, if c is a constant, log of 1 plus r or something. If you want to see these programming, again, I have one code for this, where we have this information like, if you run this code, you can see here this image gives, this is the original image, this is the negative or inverted version of this image, this is the darkening, intensity lowering kind of thing, and this is the intensity brightening kind of thing. So actually the operations that we have done here is that in one case we have half the intensity, in one case we have double the intensity, and in one case we have made the intensity negative. So 1 minus 2, say 1 minus the intensity, or 255 minus the intensity is a negative one. So these are the common ones. Next, coming to the here, I have not yet discussed the frequency domain operation, but if you have a Fourier image or a two-dimensional Fourier transform image, you can do the log operation, and you can see the spectrum in a much more details way, because the spectrum operations are generating uh, pixels which are of high range. So if you do log of this range is more clear, as you can see in the right hand side. So you can do power law transformation with different values of gamma, where gamma is the power and c into r to the power gamma. Here I have used c equal to 1, but you can use any value of c. And this kind of more changing of input and output relationship you might have seen in the normal what we have in Adobe Photoshop or any picture editor. You pull the intensity and change the things. So varying the gamma, the whole family of curves are there. So whether gamma equal to 1 or gamma is less than 1 or more than 1, you have the changes. So to see this, this is a spinal cord, and here there is some breakage. So if you take gamma equal to zero point 0.6, you can see some amount of breakage. As you zoom in, this becomes bigger and clearer, and you can see here the crack is more visible in when you do gamma say zero point 0.4 or say zero point 0.6 or zero point 0.3 compared to what it was in our original MRI magnetic resonance image, MRI image of this fractured human spine. So same for this kind of haze based works where low visibility is there. You can apply gamma equal to 5 or say 3 or say 4, and you can improve the quality of image. So the aerial view of the runway is much more better when you are using gamma more than one. Whereas for the bone, it works better when gamma is. So we had in earlier days CRT monitors, we had gamma correction, which was done for correction of the thing. You can have various contrast issues in this way. But before going to that, let us go for the gamma correction thing. So coming here, you can have the gamma transforms. So here I have used a few different gammas. You can see this is for uh, gamma being so uh, point 2 or point, this is 2, 5, 10. This is what for we had done for the aerial view. And similarly, if you do for point 2, point 4, point 6, point 8, these are the views for different gamma for the original image. This one. So these are the gamma transforms that you can do. Similarly, you can do various linear operations, which I have already discussed, means image brightening and other things. This I have already discussed. And next, you have the nonlinear operations. Uh, if you go ahead, if you have different contrast changes, you can do. Then you can do piecewise linear transformation. Like I can use different intensities here, different intensities here, and different here. So I can regulate the image output, or we can see different contrast stretching in the linear transform. For poor quality images, we can make changes like, or if my region of interest is this, and I can say I want to magnify only this part, or I want to enhance this part or this set of pixels. This can be done. We can highlight uh, the features. Say there are some labels can be suppressed or maintained, whereas some features can be highlighted in real level slicing. So before going to the bitplane slicing, let me discuss the operation for piecewise linear. If I do piecewise linear operation, like if I see this one, this is a piecewise linear operation. What we have done here is that here we have made from 0 to 50, they are all made 0, and from 50 to 200 it is continuously linearly increasing, whereas from 200 to 50 all the pixels are made something like 50 or 30 kind of thing. So you can see this is a piecewise linear operation, and you can do nonlinear operations like say exponential operation, square root operation, nth power operation. You can do a lot of point processing things here. So coming to the bit plane slicing, what we are doing here is that if it is a 8-bit system, what we do here is that we know that we have the last bit to be 0, it is the LSB, and the highest bit to be 7 or MSB. So in between, what we can do, this gray image can be divided into say different parts by bit plane slicing. So if we do for $1, we can get this particular thing, and the last one, the MSB one, will be the binary version of this image. So you can see here, this is the bit plane slicing of the different things, and the LSB will occur like a noisy image, whereas the MSB will work like a binary image, and it will be thresholded at zero point 0.5. So you can reconstruct the different images with different bit planes, and you can have different set of images based on if you want to remove the noise, or you can enhance some security features here. A lot of security works are done in this way. Here I have done bit plane slicing for the cameraman image, which I have been using through. So if you see, this is LSB position for 1 2 3 4 0, then bit position 2 3 4 5 6 7, and this MSB position, that is the bit position 8, where it is 2 to the power 7. So you have the MSB here, which gives you the binary version of the thing, or you can say thresholded version with 0 2.5, and you can have a lot of different things here. Going ahead, you have this reconstructed with different bit planes. You can remove noise. So to summarize, in this lecture, we have looked into the enhancement based on histogram, point processing, and we are continuing the different enhancement techniques. Basic idea of any enhancement technique, as I told in case of the histogram image processing, is that we want to make the image look better or whatever is our region of interest. Next time we'll look into the neighborhood operations, particularly for filtering and convolution. So till then, you can look into the point processing and histogram based image enhancement techniques. So thank you for now. So I'm closing off here. So thank you very much.